So hello everyone. So I am today I am learning about Rust lifetime. So in this week, what we are learning, uh, at first you already see the description. 20% of Rust, it will cover 80% task in Rust. So the 20% of Rust is ownership, borrowing, lifetime basic, structure, enum, pattern matching, trade, generic, state bound, and error handling, result option. So we already cover ownership and borrowing. Ownership and borrowing. We already cover ownership and borrowing. So today I will learn lifetime basics and structure enum. We will started with Rust example 100 example. After that we will practice it in VS Code, right? So let's jump into 100 exercise to Rust, to learn Rust. So here we should start. So lifetimes, first topic is lifetimes. So what is lifetimes? Lifetime is a label used by the Rust compiler to keep track how long the reference, either mutable or immutable, that is valid. That means if we want to understand what is lifetime, then there should like something like that. Sorry. Okay, so okay, let's assume this is a let's assume this is a function. So the function, at first we should understand the lifetime, right? So it is a and it is b, right? Sorry, a and this is place b. Okay, so this component will travel this path and end in place b. So after travel to place b, this component will destroy or will end his life, or end his life cycle, or end his journey in b, place b. So what we understand that lifetime is lifetime is something like that. Okay, so lifetime is something like that. You have something and it complete his journey another place, and after complete it destroy, or it is just out of scope. So it is normal concept, but in Rust how we define lifetime and how we use lifetime. So if we see this example, you can see that there is something like slash a and t. So at first we should we should understand that lifetime, if it is a generic, right? We will discuss in future, but now we will see this part, that is point A. So parameter A, parameter A is lifetime. So how we can understand this is lifetime? So you can see this clone, so we use this before a lifetime characteristic, so lifetime letter. So this is the main thing about the syntax. You will get lifetime by using this comma. So now we should see how the lifetime work. So here you can see there is two generics, t is implemented in the vector. So sorry, there is not two generics, there is one generics. And I think what is going on, let's assume that it is a iterator function. Okay, so it is generics plus lifetime. So it is okay, this new concept for me, it is generics plus lifetime. Okay, and we are sending a reference of a self and the lifetime is A. So what we are sending in this function is self, and it will it is the input, and the output will iterator. I don't understand this part. We should Google it, right? So let's see, we should Google it, right? So sorry, no thanks. Okay, okay, so we should understand this part. So what is going on in this part? We don't understand this part. Let's Gemini it. So what is going on, what is GOIN going on in this part, PRT part, what is going on in this part? Okay, let's see what Gemini give us. So here what we saw, there is a vector that is iterate. It is generics over a lifetime parameter named A. So we already discussed that it is a lifetime parameter on the top of generics. Okay, so A is used tied together lifetime of the vector and lifetime of the iterator returned by the iter. In plain English, iter returned by the iter cannot outlive the vector reference and self. It was created from this important because okay, return the reference of the element. So as we discuss, return, okay, it is written iterator over reference to vector elements. Okay, it is vector is dropped, the reference returned by the iterator be invalid. Here we say they are saying that if the vector is dropped, the reference returned by the iterator would be invalid. Okay, so if the vector is dropped, then if the vector is dropped, then the reference will invalid, right? The iterator would invalid. That means what they are saying. Okay, so let's assume this is not, this is a vector and this is the path, this is the journey. Okay, this is the journey. So if the vector is move out, let's say remove from this journey, then the mechanism, right, this is the mechanism, right? M A C A N I S mechanism. This is the way, or okay, way. So if this vector is moved from this way, then we will see something like that. There is nothing. Let's say this is the this is the cargo, this is a van. So in this van it is carrying vector. So in this journey we just in this journey the vector is removed from the van. Okay, so when, so if the journey is complete, the place B, in place B, and if there is no van vector in the van or no element in the van, the journey will incomplete, because if we don't have the vector, right? So we don't have that thing we needed to complete the journey. So they are saying, I think they are saying like that. So Gemini also answers. So okay, they are saying that the mechanism breakdown. So lifetime constraint. Okay, it is lifetime is a name. It explicitly detect a memory dependency by defining f iter a. So self iter a. The compile enforce static rules. The return iterator vector iterator object cannot be outlive the vector. Vector it is borrow from it. The vector is dropped, push to or moved while the data exists. The borrow checker will halt compilation. The UARANT is zero cost memory safety. The iterator is read-only viewpoint into vector heaps. Allocate A is the temporary locked. Okay. Okay. Slide. So Mhm. To the current. Okay, so we should jump into let's say we should jump into the real example of iterator. So let's jump into the real example of iterator, right? So first we have to let's say we have a vast ticket. So okay, you see the structure ticket. Okay, ticket. Okay, and this ticket has a lifetime. Let's say it is a generics, it has a generics lifetime. Yes, we have generic lifetime. So what lifetime parameter a is never used. Okay, we will use it in future, no problem. pub. So now we will have an enum. So status enum. So we will discuss that enum next in the next page of the video. Let's write st en enum status. Okay, to do in progress and progress done. Okay, pub structure t integrate as t store. Okay, so we take a structure that is a that is have a lifetime, that is comma a. So take ticket, we have a vector of ticket, so that is like a array, right? This is our ticket store. So now we will implement the ticket store impl. So okay, the ticket store at the rate. Okay, okay, right? Right, I understand. Sorry for the inconvenient. Oh shit. Okay, so we will implement the ticket store. Here we should have new, right? pub fn aw new ticket store. Okay, you can see this. Okay, we will use it, no problem. So here you can see we implement a ticket store. We take a new ticket store here. We will store in this part. Okay, so we take we allocate a new ticket store vector. So here you can see vector new and public add a ticket function and get a ticket function, and we are using lifetime on this ticket, right? Okay, now this part is done. Now we have to we will add another function, that is pub fn it iter so okay, okay, okay. So iter over the ticket, right? So now we have if we went we have description right here, we can see a description, but we want long description in the ticket. So how we will do that is, we will need a pub fn get long description. Okay, so you can see here we just have a longer description. You can see this is out of the scope of this iterator, and it is on the road. So like here the lifetime will over, but in this specific for this specific task, like we want a lifetime on this part. Why we need, I will explain you when we write the main function. In that time we will see that, right? Okay, so here we should have something like ticket A and ticket B. Sorry, we have some mistake, that is ticket 1 is what we will send a reference, and percent A and a ticket. Okay, there is too much smarter nowadays. So you can see this part, we just send a ticket 1 and ticket 2, and both have lifetime reference and lifetime. This is a reference and this is a lifetime. So why we need this? Because the here in the main function, when we write the main function, you will see this part, when this part will execute, because of the lifetime we can access this part easily, right? So we will see what will on side of main function. Okay, let mute let mute store ticket store new. Okay, and we have ticket 1. Okay, right? Okay, so ticket 2 same feature to okay, so add store plus add ticket 2 ticket 1 ticket 2. That means we are saving this on using by using add. So in add we just push in the self. So self is ticket self is a vector, right? So the self is a vector, so we are pushing in the vector, like adding store 2. Now we can see, we can print that. After printing we will see this. Then nowadays the AI is really good. we that's why our task is too easy, but day by day we are too behind, or we didn't understand the core things of this of the code. So we will give an example of lifetime. We already we discussed that. In this part we will show you why we need lifetime, right? So get loan longer DESCRIP and description. Get okay, longer description. We will send we will send percentage ticket 1 and ticket 1 and ticket 2. So if borrow of move, okay, so here we have an error that is saying that this borrow has been moved to this part. Okay, so why this happened, let's check out. Okay, so here we just so we didn't give the copy trait, so that is the problem we are facing. That means we have to copy that. We can use driver, so we will use driver driver clone and clone debug, but E Q. Okay, okay, and we miss something, that is hash. Sorry, that is hash. So because without using hash we can't use the driver function, right? So Okay, clone. Yeah, we need lots more thing in this part. So, and another thing is what this error saying, that is self ticket 1. So this parameter takes ownership of the value, so we need to use clone, because we are just okay, we are facing in this line, we are facing problem. Sorry, what is going on in here? Sorry, where we are? Okay, so we are facing this problem because of this. So this function just you can see add trick. So add trick just take the ownership and push it in the ticket, so we have to give the ownership, so that's why we will clone it, right? And here, okay, I think we have some error problem. So lifetime parameter is never used. That means if we don't use lifetime, then it will not a big deal, right? No, it will big deal, but here we didn't use the lifetime, right? No, we use lots of them. So let's see if that is compiled, that means our code is okay and we can move forward. And okay, it was okay. Oh, okay, sorry. Okay, so we have facing error, that is unused lifetime parameter. So remove lifetime reference field such as phantom data, never use. So okay, so let's see how can we solve this unused lifetime parameter. So this is the core problem we are facing. They're saying we should remove it. Okay, if we remove it, what will happen? If we remove it, what will happen? Okay, nothing happening. Okay, we don't need lifetime in ticket, right? Ticket store, sorry. If we want to see quick fix, what will happen? Okay, uh, okay, we just making mistake, right? Make mistake, so yes, we cut off lifetime, but in this function we have that lifetime, right? So okay, mm, mm, cargo. Okay, we finish it. Cargo run, we will run it. Build, we build, and we just run this program. So this is the part. Title, to do, description, status in progress, and final is there is bug in the code that need to be fixed. So if we don't use lifetime in this function, what will happen? Let's see the error. Let's compile lifetimes been generate 3 warning, could not compile lifetime be due to previous error. Okay, so if we delete from this part, what will happen, right? Okay, I could not compile lifetime. Why we need lifetime? So if we ask to Gemini why we need lifetime in this, what she answer me? Let's see. Okay, so I am learning Rust, right? If you guys or you people are also learning Rust, then we can connect and we can share our thoughts on this topic, and hopefully that will increase our knowledge. So feel free to connect with us. Okay, so we will ask why this lifetime needed. So, okay, why this lifetime. Okay. Okay, so analyze the memory dependency graph. Compiler is okay, introduce hazards. So the function accepts single reference to reference compiler automatically link the lifetime by lifetime. However, use single takes to disjoint reference. Okay, so what is lifetime rules? The rules. What are the lifetime rules? So then the mapping to the return time for static rules. The return pointer is mathematically claimed to live only as long as the shortest temporary scope. Okay, so arguing your previous failure against the algorithm. No. Function get longer description. Okay, exam one. So here we can see we get longer description. I'm saying no, atomic one applies T1 get T2 get B. Exam to fail there are two input not one. Okay, there are two input not one. Exam is no, there's no self receive. The algorithm is without mapping the return time. Okay, on to forcing you to map the memory to the memory in your. Okay, the core thing is when we compile a program, the borrow checker evaluate every function sign against three immutable axiom. The sign failed through all three rules without the output memory boundary on that means distinct temporal boundary for input. Distinct temporal boundary for input. First rules is distinct temporal boundary for input, right? First rule is this. What is this? Okay, each unannotated reference in the input parameter list receive in own unique lifetime. Okay, that's great. So the compiler assume not to share memory intersection by default. Not to share memory by default. Okay, and single source of truth. It is an important part. Single source of truth. Okay. Each is input in the input parameter list receives its own unique lifetime. The compiler okay. block, sorry, block. Okay, okay, that means um, it means okay, sorry, it means if we the compiler assume no sharing memory instruction by default. By default there is no memory sharing. If we have generics and a lifetime, the compiler will understand the connection between the entities, right? So yes, so this is okay. Sorry for the inconvenient. We can use link paste code blocks, Rust, right? Rust. Okay. On lifetimes. Okay. Right, so we have that in our notes. That is my notes. So you can also build your own notes, so that in future if you have to revise, then you can easily revise it, right? Single source of truth. So if there is a exactly one input lifetime parameter, regularly or explicitly, the extra lifetime is automatically assigned to all deleted output lifetime. The okay, that means if one input or one lifetime, that will be implemented in total whole. Okay, I understand that. So we have second part, that is single source of truth, and you can see here. Okay, we just give a one lifetime and it is implement the whole function. Okay, so right. Rust. Okay, single source of truth and structural own priority. Okay, third is structural own priority. Okay, so if there are three mutable input lifetime parameter, but one of them is bound to end self or mute self, meaning this is a method of a structure, the lifetime of the self inputs assigned to all elder output lifetimes. On a structure, this is a method on a structure. Okay, that means if the multiple input lifetime parameter but one of them is bound to self or mute self, means this is method on structure. On dedicate the memory bound of on derived state. Okay, okay, so we have rust and lifetime. Okay, so yeah, so the main concept we just find that is there is no percentage self fail, there is no okay, without mapping the return type. Okay, here we can see if the full input lifetime parameter but one of them is bound to self or mutable self, that means lifetime of the self is fully assigned to all endpoint. Okay, I understand it. And then this that means that means if there are multiple input, then if there are multiple input in lifetime parameter but one of them is bound to be self or mutable self, that means one of them are self, right? One of them are self and meaning this is method on structure, that means it is method on structure. The lifetime of self is forcefully assigned to all the elite output lifetime. In system architecture, the structure own dedicate the memory boundary is derived state. Okay, I understand that. So that means it is a method on structure if there is self or lifetime self. We have to assign all the elite output lifetimes. The system architecture. Okay, so we already complete the lifetime part. So there is so there is three core thing in lifetime: distinct temporally bound for input, single source of truth, and structural own property. We just learn. Now we will implement in our project. Next we will implement in our project. So why lifetime is important? Because if we don't have lifetime, then um, in this part, okay, sorry, sorry, here we should have a lifetime, right? Okay, right. So if we don't have lifetime, then when we push this ticket 1, ticket 2, in that time let's say if the description length greater than t2 length equal to t1 description, so it will we will face a lifetime error. How it will, how there here we need, why we need lifetime? Let's see why we need lifetime. What Gemini said to us. Why, sorry, why we need lifetime. Okay, why we need lifetime? That is a question to me, to myself, and I can't answer. That is why I am just okay. Answer the deterministic memory safety without garbage collector. Okay, so here the pointer I am returning is physical embedded inside either t1 or t2, therefore the caller is statically forbidden forbidden from dropping either, and while they are still loading this output in the point. So okay, and the thread and the user of analyze your function operator reality and does not return you it. Okay, it doesn't, right? It reach out physically memory block or either to grab each memory address of description field and hand to raw pointer back to the caller. Okay, t1 t2, so where we just write t1 and t2, so here is t1 and t2. What they are doing, grab the exact memory address of the description field and hand the raw pointer back to the caller. Image a scenario where the compiler did not enforce lifetime and caller execute the sequence, allocate stack on the resulting pointer in logger description, drop target from memory. Each memory block is making mark as a free override by the other operation. Okay, ticket 1 from the memory is the memory store the pointer to long description. Okay, it when we call this, it stored the resulting pointer in the logger description. Okay, okay. That means in this part, when we call them, in that time, and the store, their calling store result will point in a longer description. Longer description. Okay, longer point in longer description. Okay, that will point in longer description, right? And drop ticket from the memory is the memory block is may act as a free and immediately overwrite by other operation attempt to read logger. If the logger description was pointed to ticket, it was dangling pointer. Okay, in the pointer corrupted overwrite memory C or C++ the causes segmentation fault or silent data corruption data in our okay, I understand that. Mainly because of garbage collection, because of pointer, right? It is it is just give a reference. So if we just remove the memory blocks makes as a free and immediately override by the operation of ticket from memory. So if the tickets from memory, if the ticket 1 is dropped from the memory, it will immediately override the operation. That means the pointer, we have the pointer address pointer that will overwrite by the other operation. So that means we can't read logger description after that. That is why we need lifetime. Okay, I understand this. Okay, do you guys understand? Let's say, so we have to ticket 1, ticket 2, and we pass this on this function. Now problem is, if we don't have lifetime, that time and we also pointing logger description in this after in the next line. If we drop ticket 1, let's say in this line ticket 1, if we drop ticket 1, and that will empty the memory space and the pointer address. That after that, if we want to let's say we want to print ticket 1, but ticket 1 address is already overwrite because the it dropped the drop memory from it, just drop the pointer is now rewrite and new pointer replace this. That is why, because we need a pointer, so that is why I think lifetime needed. So if we want to understand a core thing, it may be like that. Maybe like that. So this is the pointer pointer DDRE address of a function of a function pointer address, address of a function. So now pointer of a function. Now and we will now a function of a variable variable, then and we are fetching from var from this pointer. We are fetching the var from this pointer. If we, let's say, a new if the new pointer new okay, we drop from the memory. If we drop this drop from the memory, drop the pointer pointer from the memory, then it will get drop from the memory, drop from the memory, pointer from the memory. Now okay, so now this is one, okay, Control G, okay, sorry, okay, new find and now here will find and define new and DREWS in the POINTER lifetime LIF will we give us a give VARI variable time. Okay, lifetime can give the variable time. Okay, we'll find new address in the pointer lifetime time. Okay, that is the main point of lifetime, right? Okay, so that's done. So we already done the lifetime basics, and next we will have what we will have structure and enum. We already saw structure an enum. So this is an enum is like um, uh, enum is like switch case. That means we can use only one thing from this. Here you can see an example, right? This so we can use a status only one status from the status enum. We can't use two status in from the enum. Here you can see one status to do or in progress. So this is an enum. And structure you already understand that, you know, that is a structure. You can have we will discuss much more deeply about the structure. So that's it. Thank you everyone. So stay connect with me. I am learning Rust. If you guys are learning Rust, then we can share our knowledge